All right, we'll do another one real quick here. So the other one that I want to look at was, we talked a little bit about this in class. This is the one with the garden. Basically, in the diagram, they give you the dimensions of the garden and tells you what it has to equal. So this one is really, really fast. You just wind up with 60x minus x squared is 800. What I always do is get a positive value of my x squared. So I get x squared minus 60x plus 800 is 0. And from here, you can use quadratic formula or you can factor it. This is a pretty quick factoring problem. It's 20 and 60. I'm sorry, 20 and 40. So it's x minus 20 and x minus 40. So you have 20 and 40 for your two dimensions. So if you put your x value of 20, and then this becomes 40. Okay. And then while I'm using this one, since it's already up, let's look at the firefighter one. And the firefighter one was question number 9 on the sheet here, or the page 9, I should say. So in this one, you've got the firefighting stream. So you're basically looking at a graph like this. You're standing on the ground, your fire hose goes up and down, and it wants to hit a window height that is at 25 feet. Okay. So you have to figure out what are the two distances that you can stand that the fire hose can get to. So basically what we have to do is just set this equation equal to 25. Now it looks really, really weird when you write that out like that. So you get, let's see, negative 0.003x squared plus 0.62x plus 3 is 25. From here, then we just go ahead and use quadratic formula. Negative 0.003x squared plus 0.62x minus 22. Do that first, set it equal to 0. And then you just have to be very careful with how you type things in the calculator. So option B, 0.62 plus or minus the square root 0.62 squared minus 4 times negative 0.003. When I did this problem earlier, I think I forgot one of the zeros by mistake. So just be very, very careful. All over 2 times negative 0.003. So when I did this, I got negative 0.62 plus or minus 0.35. I think I had to round that hair, divided by 0.006. And it gives me two values here. One of them at 45, and that's clean. And the other one at 161.67 when I rounded that out. So those are the two distances that the fire hose can reach. Okay. Hopefully that'll help you out with those. Like I said, on Wednesday, what we're going to look at. Oh, I'm sorry, I almost forgot. On the volcano one. Oh, we have aviation first. So aviation is number 11. Forgot we looked at that one. Again, in this case here, bless you. In this case here, we're just taking the formula they give us: 0.1 s squared minus 3s plus 22, and we set it equal to 2,000 because they're trying to figure out what's the speed that you can go. This sets you up again for a very easy quadratic formula problem with 1s squared minus 3s minus 1978. So let's see, 3 plus or minus square root, negative 3 squared minus 4 times 1 times negative 1978, all over 2 times 1. From here, you wind up with values of 3 plus or minus 28.29, all over 0.2. Obviously, when I subtract this, I can get a negative value. You can't have negative speed, so we know that's not going to work. But the other one was roughly giving us 156.45, I think, speed per second. You don't have to worry about labels, I'm not going to worry about it. And then the last one real fast was the initial velocity, or the volcano one. In this case here, oops, picture. The first question said, talk about initial velocity. Initial velocity is this 350. I'm not going to ask you that question, so you don't have to worry about that. The other one was, when you're looking at the graph, remember it's going to go up and down because it's negative. Basically, all I would do is throw this into my calculator and figure out and calculate where that 0 is, because this is your time. And this tells you how many seconds it hits until it takes to hit the ground. So if we did that in the calculator real fast, I go to my y equals, excuse me, back that out, negative 16. Obviously, we're using x, because that's what we have, x. One there. Again. negative in, so negative 16x squared plus 350x. And we go to our graph, and we'll see if we can find where our zero occurs. Oh, my graph was all messed up from earlier anyway, so I need to calculate that zero. So remember, second trace, we're going to calculate zero, enter it. Left bound, we got to figure out where we're at. Oh, my y value is negative, so I have to move to the left. Try to find out where my y value becomes positive. Might take a little while, because I had to reset my calculator. No big deal, we're getting there. Oh, we are positive. Let's see. I jump between here and here, so I'll hit my left bound, then I'll hit my right bound. Yes, and what is it, 21.878? Yep, so basically at 21.875 seconds, it takes for the lava to go and then blow up the outside world. It's a great